10 days of solar explosions just ended. 6 X-class flares erupted, and one reached an intensity of 8.1, which is massive by any standard. Sunspot Group 4366 was responsible for this activity, and now that group is beginning to break apart. That shift does not mean the danger has passed. History shows that large sunspot cores do not always calm down after they fracture. In many cases, they go quiet as they rotate across the solar disk, only to unleash a single enormous eruption without warning. This pattern appeared in 1859, again in 1921, and in 2012 when a massive event narrowly missed Earth by 9 days. Each time the trigger was a monster sunspot with a twisted, compact, and highly stressed magnetic field. Right now, Sunspot 4366 has split. Its leading core remains enormous, dominated by a single polarity and still magnetically powerful. The trailing region is developing new magnetic flux that is dense and compact. While it is not as large as 4366 was at its peak, it remains one of the most significant active regions on the solar disk. The region rotated off the Earth-facing side yesterday and is expected to return in about 18 days. Yesterday also brought a powerful eruption on the far side of the Sun. A coronal mass ejection lifted off the eastern limb and was clearly visible in coronagraph imagery. It was not aimed at Earth, but the region responsible for it will rotate into view within days, possibly sooner. This mirrors the same setup seen before the G4 geomagnetic storm in January. When 2 far-side eruptions occurred, the region turned toward Earth, and then it fired directly at us. At the same time, new solar wind impacts are arriving between February 7th and 8th. NOAA models indicate a double peak structure. While velocities are not extreme, the Earth's magnetosphere is already highly energized. The ionosphere has been continuously active for 10 straight days, which means even a minor or glancing impact can produce outsized effects. Last night in northern Sweden, a powerful substorm lit up the sky with green aurora and red high-altitude bands, lasting nearly 6 hours after the main storm phase had already ended. X-ray flux levels have dropped back into the C-class range, and the flaring has paused for now. But when the sun behaves this way, the consequences do not stop when the flares stop. Energy accumulates inside the magnetosphere, the ionosphere, and the global electric circuit. A system already charged can react strongly to smaller triggers. Under these conditions, even G1 level geomagnetic storms can suddenly intensify. Auroras may appear at lower latitudes, power grids can experience fluctuations, GPS accuracy can drift, and radio propagation can shift unexpectedly. If the far-side active region remains unstable as it rotates into view, and if it launches an Earth-directed eruption with the right magnetic orientation, the effects could be significant. Sunspot 4366 had all the ingredients needed for a Carrington-class event: size, complexity, and extreme magnetic shear. It did not happen, but the probability was not zero. Estimates ranged from 10 to 20%, which is higher than seen in months. That risk did not disappear. It simply rotated out of view. We are now in a narrow wait-and-watch window. A far-side explosion has already occurred. A new active region is about to rotate into sight. Earth's magnetic field remains unstable after 10 days of bombardment. And the core of 4366, the largest and most magnetically potent part, will return in 18 days. February is not calming down. Planetary alignments continue, an eclipse arrives on the 17th, and a Saturn-Neptune conjunction follows on the 20th. Solar activity is higher than it has been in months. The sun has already fired a warning shot. What it does next is still unfolding.